Hello everyone. While using a coding editor, have you ever wondered why do closing brackets automatically appear when we type out opening brackets as I'm doing over here on my screen? Well, the why is very simple. It's to make our lives easier. But have you wondered how does this work? Well, this particular question will give you some intuition on how would that happen. In this question, we've been given the number n and we have to form all combinations of well-formed parentheses and we have to form them using n pairs. So if we have, let's say, n is equal to 3, we should have the n number of opening brackets, n number of closing brackets. That's 3 in this case. And we have to find out all such combinations for a given number. So how do we go about it? So we'll follow the same example and then compare the results after we're done. If n is equal to 3, we have to form all our answers. So we'll start off with a blank slate. But before that, I want to discuss what does well-formed parenthesis means. It simply means that we have to start with an opening bracket and end with a closing bracket. That is a well-formed parenthesis. We cannot start a combination with an closing bracket and end it with an opening bracket. This is not valid and neither is this. And even in the middle of the combination, say you have an opening bracket over here and you have closing bracket over here, we still have more pairs to explore based on the number. You cannot have a closing bracket over here because that would mean that you have to end with an opening bracket, which is simply not logical. That is not well formed. So we cannot have that. What can we have though? That is what we are here to find out. So we start off with an empty result. In each particular chance, we get two options. Either we go with an opening bracket or we go with a closing bracket. So we ask ourselves, can we add another opening bracket over here? The answer is yes, we practically haven't started yet. So this is an opening bracket, but can we add a closing bracket? The answer is no. As we just discussed, that would not give us a well-formed parenthesis. So we do not go down this path. This is the only path that we'll be exploring. So moving this over here, we are given two options once again, opening bracket or closing bracket. We can add another opening bracket, that is valid. We can also add a closing bracket over here because the count of the closing brackets at this moment it is less than the count of the opening brackets, which is something I'll write down over here. It is important. Open count should be greater than close count. Then and only then can you add another closing bracket. All right. In this case, this was 1 and number of closing brackets was 0 so far. So we were able to accomplish this. We move on. Here we add an opening bracket. We use the same logic. Number of opening brackets will still be greater than the number of closing brackets. So we allow this to happen. Over here, on the other hand, while we can have an opening bracket over here, which would give us this, we cannot add a closing bracket because then after that is done, we will have two closing brackets as compared to only one opening bracket over here. So we cannot go down this path. Can we have more opening brackets now? The answer is no, because we already have three opening brackets and three is the number of pairs that we have to use. So we should only have three more closing brackets. And in this particular branch, that seems pretty simple to understand. So I will simply add all the remaining closing brackets because that is all that we can add now. That will give us one of our answers. How do I know that we have one of the answers and how do I determine that mathematically? That is a very important thing to know and something we'll be needing when we solve this question. The trick is very simple. Count of the opening brackets should be equal to the count of the closing brackets, and this should be equal to n. If this satisfies, we add this to the final list of answers, which will eventually be returned. But what about this particular condition? When do we know that we have reached the limit of the opening brackets? Simple. As soon as the open count becomes greater than n, we return from there. So we have these two base cases that we have to keep in mind while implementing this. For now, let's just continue with the tree to understand how the answers are formed. Continuing with opening brackets, we get this. Closing brackets would give us this. We keep going. We can only add closing brackets in this combination if you think about it. So no more opening brackets in this tree because we have 1, 2, and 3 opening brackets already. So let's add the closing brackets. That gives us a valid answer with 3 pairs. As far as this goes, we can still add an opening bracket, but we cannot add any more closing brackets to this particular answer because right now the count of open and close brackets is the same. We have to make sure that it is greater as specified over here. Since that is not happening, we do not go down that path. And over here, we will add the remaining closing bracket and form an answer. We are yet to explore this tree, so I will do that quickly. This gives us the remaining answers. And we have 5 answers over here. To compare, we can see that we have 5 combinations in this answer as well. So we are on the right track, and that is pretty much all we have to do to solve the question generate parentheses. In the next video, we will be implementing this, so stay tuned and follow for more.